In this section, section 10.2, we will discuss how to convert between a radical and a similar expression with an exponent instead of a radical. And what we're going to be working with are called rational exponents. Rational, remember, just means a ratio of integers. So here our exponents are going to be fractions, ratios of integers. When we have just an exponent of 1 over a denominator, so the numerator is 1, that is the same as the radical with the index matching the denominator. So 1 over n as an exponent would mean the nth root as a radical. So, for example, 64 to the 1/3 would be cube root of 64. Same thing. And that we can simplify to 4, because 4 times 4 times 4 is 64. And 1 over 64 to the 1/2 would be the square root, because of the power 1/2 of 1/64. And remember, when you have a fraction, you can do the square root of the numerator and the square root of the denominator, so we'd have 1 over 8. On the next one, since all of this is in parentheses with the exponent, we want the square root of everything. So we'll have the square root of 16x to the 8th, that whole quantity. And because we have a product, we can do the square roots separately. So square root of 16, that's 4. And the square root of x to the 8th. Remember, with the square root, we cut the exponent in half. So we'd have x to the 4th. And now we can see why this makes sense, right? X to the 8th to the 1/2 would just be cutting that exponent in half. So doing the square root should be the same thing. Right? So we have 4x to the 4th in that example. 8 to the 1/3 power we can rewrite as cube root of 8. And then it's easy to evaluate. That's just 2. Notice the difference between E and F. A couple differences. One is that we have a half power here and a fifth power there, but the negative is also different. On the first one, it's out, not in parentheses. In the second one, it is in parentheses. So think about your order of operations here. You would always do the exponent on the 64 before you multiply by this negative sign, -1. So really, this negative should be outside of the square root, which means it will be actually a real value. We'd have -8. But this one, the negative would be inside and we'll have a fifth root. And so the fifth root of -32, because this index is odd, we can actually evaluate that and we'll get a negative number. That would be -2. Because -2 to the 5th is -32. Moving on to G. Now, again, the negative is inside the parentheses, so it would go inside the radical when we switch to radical notation. We have a square root because the exponent is a half, and this is a problem. We'll have a non-real value because we have an even index and a negative inside. Again, in section 6.7, we will say, oh, we can write this as 8i. So if you've seen complex numbers, that's fine, but for now we'll just write it's not a real value. Now we need to look at what happens if the exponent is not just 1 over n, but is maybe some other value over n. So the numerator is not necessarily 1. What you want to do first is rewrite the fraction in lowest terms if it's not already. And then when it's in lowest terms, the denominator turns into the index, right? So n in the denominator turns into the index, and the numerator turns into the power. And you can write the power either inside the radical or outside. It's exactly the same thing either way, right? So remember, the denominator is the index and the numerator is the power either inside or outside. let's write this one both ways. So that we've got a square root because the denominator is 2, and we can either have 4 to the 5th, like that, inside, or we could have the square root of 4 and then the whole thing to the 5th power. They'll be the same. The second version is much easier to think about. Square root of 4 we can do, that's 2. 2 to the 5th is 32. In the other version, it's going to give us the same value, but we'd be thinking about the square root of 4 to the 5th. I don't know what 4 to the 5th is, and I know because of this side that when I take the square root of it, I get 32, but it's a lot easier to think of in the version on the right. Moving on to B, since the denominator is 3, we'll be talking about cube roots. And the negative should go inside the cube root because there are parentheses with it. And we can put this 4 either right next to the negative 8, or we could do like this to the 4th power. The second side is a lot easier to think about, so let's do that. Cube root of negative 8 is negative 2. And we want that to the 4th power, so that would be positive 16. Again, we've got a square root here, so square root because the 2 in the denominator, and the negative will go inside the square root because it's in parentheses. And we can either put the 3 here, or we could think of it this way. Either way, this is going to be a non-real value because the square root of negative 9 is not real. If we cube this first, it's still going to be negative, and when we try to take the square root of that value, that will be non-real. So, non-real value. Notice the similarities between D and E. Both have a 3/5 power, but in one of them the 2 is in parentheses with the x, and in the other it's not. There's a difference, and you should be able to expect a difference because they don't look the same, and think about what that would be. The first one, the exponent is only with the x, so the 2 is going to be outside the radical. We have a 5th root because of the denominator 5. We can put the x cubed inside like that, or if we prefer, we could do the 5th root of x and then cube that value. They're going to be the same thing, either one is fine. But on E, the difference will be that now the 2 is inside the radical. Oops, that should be a 5th power, or 5th root. 2x, and I don't want to do just like this because the 3 should be with also the 2 and the x, and so I can do this, or I could do the 5th root of 2x and then cube that whole thing. Either one is fine. Then on F, the last one on this page, what we need to do is take a square root because of the denominator, put 49 over 25 inside, and either do the 3rd power and then do the square root, or take the square root first and then do the 3rd power. That one's a lot easier to think about. The square root, if we do that, we'd have 7 over 5. And then if we do 7 over 5 to the 3rd, I know we're going to have 125 in the denominator. 7 to the 3rd, I think it's 243, but that's probably not right. Let's grab a calculator and check. Okay, 7 to the 3rd. Hopefully you're done by now with your 343. I was not right. So 343 instead of 243. Let's erase that. 343 over 125. Then the last thing to talk about is if we have a negative fraction as an exponent. So what are we going to mean when we have a negative exponent that's also a fraction? Remember that a negative sign always means reciprocal. So if I have a to the negative m over n, I will do the reciprocal of a to the m over n. So I don't change the exponent. Just its sign, right? So I move it to the other location and change the sign. So 64 to the negative 2/3. I don't flip this fraction. I do 1 over 64 to the 2/3, right? So the 2/3 stays, in the same order, but I take the negative off of the exponent and move the whole expression to a denominator. And then I'll have the cube root of 64 to the second power. Cube root of 64 is 4, so that's going to be 1 over 4 squared, or 1/16. There are lots of negative signs here in B. Keep in mind that a negative exponent and a negative coefficient have nothing to do with each other. They're not multiplied together, so you don't want to cancel the negatives. The negative exponent we take care of by doing reciprocal, and that doesn't change the sign on the 16, just moves the expression to the denominator and takes the negative off the exponent. So now I'm looking at 4th root of 16, 4th root of negative 16 to the 5th power. And we've got an even index, a negative value inside. That's a non-real value. So we don't need to go any further with that. Remember that when the negative exponent is in the denominator, we can move it to the numerator. So we'll have n to the 8/9. Still the 8 is in the numerator, the 9 is in the denominator of the exponent, but now the n to that power is in the numerator rather than the denominator. So switching to radicals, we'd have the 9th root of n to the 8th. D is similar, except now we've got a 5 involved in the denominator. Notice that 5 is not connected to the exponent. So we will move the y and the 3/7 up, but we'll leave the 5 where it is. So now we'll have 2 times y to the 3/7 and leave the 5 in the denominator. 3/7 exponent applies to the y only, so we need to leave the 2 out of the radical, switch to a 7th root of y cubed, and then have the 5 in the denominator. Couple more examples, just with numbers, no variables in these. Alright, so the negative exponent we take care of by doing a 1 over, switch to a positive exponent, and then use the denominator as the index. Put the 27 inside, and then square the answer. That should be 1 over 3 squared, which is 1 over 9. And then in the last one, notice the negative coefficient is not tied to the exponent. The easiest thing to do is just leave that negative in the numerator. Take the 81 down with the exponent, make it positive because there was a negative exponent. We moved it. And then we've got a 4th root because the 4 is in the denominator, of 81, and then we need that to the third power because of the 3 in the numerator. So in the simplified form, 4th root of 81 is 3, so 3 to the third will end up with 1 over 27 negative. So that's it for the rational exponents. Keep in mind that these would be useful if you need to evaluate something like on your calculator. If you want to evaluate the 5th root of 3, we don't know what that would be exactly, but you can use your calculator now and do 3 to the 1 divided by 5, because the 5th root is the same as the exponent 1/5. Sorry, let's see if we can get that calculator up and running. So 3 to the 1/5 is roughly 1.246. Right, so it's handy to be able to go back and forth between radicals and exponents so that you can use your calculator to evaluate roots.